Samsung has monopoly in the OLED market. It's the only company that has the technology to mass produce OLED. So and it sells most part of its capacity to Apple. So here we are dealing with a rather complicated relationship. They are competing in the final product market. However, they work as a supply chain partner as well. So this is what exactly called in literature as co-opetition. They are in cooperation and competition, and things can get more interesting when we consider the fact that the capacity of the supplier, here Samsung, is limited. So the supplier has a strategic decision to make how much to sell to a competing um, company, how high to set the wholesale price. Also, the buyer, in this case Apple, has a strategic decision how much to buy, how much to use the capacity of the supplier. It can buy the capacity, it can order strategically to actually lower the ability of the supplier to produce for its own brand in the final product market. Things can get even more interesting when we consider the fact that the supplier has private information about its own capacity. So the supplier is better informed about its own capacity than the buyer. So here we have information asymmetry, and consequently this is exactly what we are going to investigate in this research. In particular, we are interested in seeing that how does the supplier private information about its capacity affect the supply chain in a channel conflict environment, and also we would like to investigate the effect of supplier's capacity on the buyer's profit. So the related literature to my work, I can divide them into two parts. The first part is the one way they consider the capacitated supplier in this channel conflict environment. Two paper, one by Yang in management science and the other one by Salar. The other line of research is when they consider the asymmetric information. There are two papers by Lee when in this setting, in this co-opetition setting, um, we have asymmetric information. In Lee paper, the buyer has private information about the market size and sends a signal by its order quantity about it, and the supplier decides based on that signal how much to sell directly to the customers. Um, we have some assumption. The first one is supplier is committed to provide all the buyer's order quantity. This is exactly to avoid to say that you cannot sell what you don't have. The second assumption is that the buyer is more efficient in selling, and the cost of selling for the buyer is normalized to zero. The supplier has a selling cost of C, which is non-zero. The third assumption is that the supplier capacity is either high or low, with the probability of being high capacity is lambda. Uh, Model formulation is we have an inverse demand function, normal one. The profit function is the profit function for the supplier is what he sells directly to the customer multiplied by price minus cost of selling plus what he earns by selling to the buyer. The profit of buyer, on the other hand, is what he sells directly to the customer multiplied by price. The cost of selling is normalized to zero minus what he has to pay for the supplier. We have this capacity constraint that the amount produced should be less than the capacity of the supplier. So we have a three-stage game. On the first stage, the supplier decides on wholesale price W. On the second stage, the buyer decides on QB, this order quantity from the supplier. And on the third stage, the supplier decides on QS, how much he wants to sell directly to the customers. In At this stage of our research, we consider that the buyer cannot withhold any capacity. So whatever he orders to the supplier, he is selling in the final product market as well. Um, so let's go quickly over the full information model result. The detailed one can be found in Yang paper. However, the takeaway point is two things. The first thing is that having high capacity can hurt the profit of the supplier. The reason is that when the capacity is limited, maybe it's optimal for the buyer to buy the whole capacity with a good price to be the monopoly in the final product market. However, when the capacity is high, then the supplier cannot commit not to sell directly, not to enter the market. So consequently, the buyer won't pay that high wholesale price, and this can hurt the profit of the supplier. The other takeaway point is in the optimal solution of the game, when the capacity is low, the low capacity supplier always direct sell the remaining capacity. So whatever remains from its capacity after it provides the order quantity of the buyer. However, when the capacity is high, we have a stackable kind of game, and the supplier always direct sell the optimal solution of that game, which is not related to the capacity. When the buyer does not know the capacity of the supplier, it's private information to the supplier itself, then we have asymmetric information game. The supplier sends a signal about its capacity by the wholesale price. We assume that the low capacity supplier cannot pretend to be high capacity, because we assume that the supplier is committed to provide the order quantity. However, the reverse is possible. When the capacity is high, the high capacity supplier can pretend to be low capacity supplier. Why the high capacity supplier may want to pretend? For two reasons. First of all, we saw in this previous slide that having higher capacity can hurt the profit of the supplier. So actually, in this region, the lower capacity, the supplier with lower capacity actually earns more. The other reason is that actually the high capacity supplier may want to pretend to be low capacity to set a high wholesale price, and then also produce in the final product market. So enjoy both channel fully, set high wholesale price, and also using the direct selling channel. So we can see from this graph as an example that this dotted line is the profit of the high capacity supplier in the full information game, and this is the profit of high capacity supplier when he sets a high wholesale price of the low capacity one, and also producing the final product market. So we can see that after a certain threshold, K1, the high capacity supplier has incentive to mimic the behavior of the low capacity supplier. So if game theory is part of your research interest, you probably know that in the asymmetric information game, we have two type of equilibrium, separating and pooling. Also we can have hybrid, but we didn't consider that here. So in the separating equilibrium, the agent with high information actually they send a different signal based on their types, and the agent with less information can distinguish the type by that signal. However, in the pooling, both the type, all the type of the agent with more information sends the same signal, and the agent with less information cannot distinguish. So in our game, in the separating equilibrium, the low capacity supplier cannot charge this high wholesale price. It has to lower the wholesale price to an extent that the high capacity supplier has no incentive to mimic. So in other words, it lowers the wholesale price to an extent that the high capacity supplier is better off by telling the truth, by not pretending. So in this graph you can see things more clearly. So this line is the wholesale price of the low capacity supplier in the full information game. It needs to down distort the wholesale price so that the high capacity supplier has no incentive to mimic. So if you remember, before K1, the high capacity supplier wouldn't mimic anybody. So before K1, we have separating equilibrium. We have the full information equilibrium works, but after K1, when the high capacity supplier has incentive to mimic, we need to down distort the wholesale price. In the pooling equilibrium, the buyer maximizes the expected profit. So the buyer cannot distinguish by the wholesale price the type of the supplier. So it maximizes the expected profit, and the point here is that since the high capacity supplier wants to mimic the behavior of the low capacity supplier, so the high capacity supplier actually sets the optimum wholesale price of the low capacity type. Otherwise, if it sets something which is not optimal for the low type, then it's going to reveal its type. So what is important in the pooling equilibrium is the wholesale price of the low capacity type, because the high capacity supplier is going to use the same wholesale price anyway. So in order to come with the final equilibrium, so each agent on the first stage has one choice to make. So he can choose between the pooling and separating, the maximizing the profit based on the wholesale price, and then choosing to have a separating or pooling equilibrium. We are going to have a pooling equilibrium if both agents prefer to have pooling. If one of the agents, if one of the suppliers wants to have a separating equilibrium, then it's going to reveal its type, and then we are going to have a separating equilibrium. So here is an example of how we come up with the final equilibrium. This line is the profit of the high capacity supplier in the separating equilibrium. This one is the profit of the high capacity supplier in the pooling equilibrium, and we can see that after this point, then the high capacity supplier prefers the pooling equilibrium. This is the result for this is the same concept for the low capacity supplier as well. Here we can see that after